pressing the floor when I open the door for her. She acting like a whore and I'm a letter. Learn from Project Patch.
Hello and welcome to the practice problems video on graphs of exponential functions. Okay, here's problem number 1. Looks fun, doesn't it? It says match each function with one of the graphs below. So we have 6 different functions here and 6 different graphs of functions. Okay, so let's see what's really going on here. So let's just keep in mind the general form of an exponential function. So we have f is equal to a times b to the x. So we know that a tells us our initial value or our vertical intercept, okay? So we see, first of all, that we notice from these 6 functions over here on the left side, we see that all of them have a coefficient, a very frontmost coefficient of 2, except for these ones. This one right here, and this one right here. I should actually draw the arrow pointing the other way, shouldn't I? So this one right there and that one right there have a values of 4 each, right? So that means that their vertical intercept is going to be 4. So they either have to be this D graph or the C one, okay? So how are we going to determine that? Well, D is increasing. It's an exponentially growing graph. And C is an example of exponential decay, right? So what does that tell you? That depends on B, right? So when B is less than 1, then we have exponential decay when our A is positive. So that means that this one right here has to belong to one that looks like it's exponentially decaying. So that means that our answer is going to be C for this last one down there. Okay, so that's C. And then, so the other one has to be D. And we can check that by seeing that, well, A is 4, which is positive, okay? So when A is positive and B is greater than 1, then we have exponential growth, as we see here in that graph, okay? So we're done with those, done with C and done with D. And now let's look at all these other ones. So we can't really use A to be a determining factor because all of our A's here are 2, okay? So we can't use those, but we can look at, so we can kind of use the same trick here and say that, well, when our B is less than 1, because we know our A is already positive, right? 2 is greater than 0. So now that our B, when we have B being less than 1, that means we'll have a case of exponential decay, right? So it could either be B or A. But then our job is to determine, well, which one's which? Because if both of them are exponentially decreasing, exponentially decaying, how am I supposed to tell which one is which? So first of all, let's find the ones where the B is less than 1. So that would be this one right here, as well as this one right here, okay? Because the other ones, 1.28 and 1.59, those are definitely greater than 1. So those will be exponential growth. But anyways, let's look at the ones that I just drew arrows on, okay? So we see that, well, let me introduce another kind of side concept, that if our B is equal to 1, let's say, then what we're going to have is this function. F of x is equal to a. So then we would have f of x is equal to a times 1 to the x, which this is always going to be 1. So we have f of x is equal to a. And that right there looks like a constant function to me, right? So that's going to be pretty much a straight line. Okay, so what we can determine from this, what we can take away, is that when our b gets closer to 1, okay, then we have a kind of a less steep graph going on, okay? So what do I mean by that? By that, I just mean to say that as I basically just said it. So as b gets closer to 1, in that this 0.81 is closer to 1 than 0.69. So this one right here, the one that I'm putting a box around, this one is going to be closer to a line or less steep than the other one. Okay, so if we look at A versus B here, we see that A is less steep than B, right? So A must correspond to this function right here, and B is then left for the other one. Okay, now let's determine the last two. Now we're between E and F. So we see we have this 1.28 and 1.59 to decide between. So again, the same concept applies, is that when you have a B that is closer to 1, then you're going to have a more shallow graph that looks a little bit more horizontal than the other one. Okay, so this 1.28 is closest to 1. Well, it's closer to 1 than 1.59. So that means that this one right here, this 1.28, is going to have to be the less steep one. So that'll be F. Okay, so this one's F, and the last one is going to be E there. Alrighty? And we are done.
Money make the crowd go down.